Can we go a little bit into the topic of real-time machine learning? Because I know that if I remember correctly, Tecton is pretty bullish on real-time feature engineering compared to other feature stores. Can you go a little bit deeper into how it's going and is it needed?
And what is it about? For me, who is not following so deeply feature store space, what real-time feature store is about, like to start?
So let's take a step back and talk about like why would you ever care about real time? Who cares about this? And so I think there's a little bit of like a data maturity thing that people go through. So when we talk to companies, there's some companies who are just at this stage where they're just like, we have all of our data. We don't even know where it is. It's all over. It's in random databases in the company. I don't even know how to access the data. So that's kind of like the least mature kind of, or we don't even have data, right? But over time, companies get to the stage where they've got their data together. They put it on a data lake or a data warehouse. It's on the cloud. It's kind of like in this, place where people know how to access it, and maybe they can start doing proper governance and BI on it and stuff like that. So then the next natural thing is let's get some analytics from this thing. Like let's use this data for something useful. The easiest thing to use the data for is to extract patterns, to make dashboards, to make decisions, all this internal stuff. Let's have a meeting. Let's look at the data. Let's make some decisions, right? Or let's pull up the dashboard, or do alerting or something like that. But then you kind of get to this, okay, we've done that, but how do we actually use this data how do we get more value out of this data? How do we use this data to affect our customers? This is kind of the same question we were talking about, like the Uber thing, where they were like, let's do something cool with this data. Let's use it. Let's differentiate our product. Let's make our product better. So that's when you get to this set of decisions that need to be made with the data that happen at a speed and a scale that you can't really have a human in the loop. And when that happens, you need to productionize things. It's got to be, if you're going to use it to affect your customer experience, it's got to be productionized. It becomes a little bit of an engineering problem too. And you have all of these requirements. It's got a certain level of availability. It's got a certain speed that needs to happen, certain, cost requirements because it's like a certain scale. So that's when you have machine learning in production. That's like how people get to the point of machine learning in production. And they want to use machine learning for a variety of problems. The highest value problems, though, are every company has, like what we've seen is like there's a variety of use cases that kind of are this is the most important use case for us. And then we have this like long tail of ML use cases. When we look at what are the most important use cases for companies, it tends to be stuff that like directly makes money for them or directly prevents them from losing money, right? And so these are recommendations. If you make better recommendations, you're making more sales. Fraud detection. This is like, if we prevent fraud, we're saving a lot of money. Pricing, better pricing, risk decisioning. So like stuff like real-time underwriting, or underwriting from if you sign up for insurance or a credit card or something like that. And so all of these use cases, the ideal user experience, kind of like if you're competing against your competitor as one of these companies who's in banking, is in insurance, is in fintech, whatever it is, you're getting pushed to go faster and faster. A better user experience is a faster user experience. And I'll give you an example from a specific customer that we have. They are an insurance company, and if you would sign up for insurance with them, they run everything on a mainframe, like on their data center, and they couldn't give you a quote. They had to take that quote, they had to take all your information, they had to go back to like literally put it in some queue, and overnight the mainframe would process it, and the guy would call you the next day and say, this is how much we can give you this policy for. So they're all about like, how do we just go faster with this thing? How do we make like an instant experience for our customers? So all of these companies are trying to just build a higher quality experience for their customers, and that means going faster. So that motivates real time. And so
it is near real time still, right? Because we are talking about kind of extreme batch overnight processing of requests for credit, right?
Well, what I just told you was the overnight thing, and I'm saying
Yeah.
that was too slow for this insurance company. They were like, "This is dumb that we have to do this.
Yeah.
Why can't we? Why can't we have in the app? You say, okay, now I want to sign up, and it gives you your price instantly, right?
But instantly, 1 minute will be fine. Or we are looking here.
Well, they want it.
Below.
I mean, they want to give you the price instantly. Like you know,
Okay,
it's kind of like if you search Google and then Google's like, okay, we'll give you your results in 1 minute, right? You get a lot of drop off there. So all of these things, like certainly getting it 1 minute later is better than getting it 24 hours later. But you know, if you have your competitor who's going to give it 30 seconds or 1 second later, then that's your incentive to go faster, right? And that's why Google's super fast. And all of these companies, they want to be super fast as well. And so just to like think of some other examples where speed is important, you're processing a payment and you have to decide, should I allow this or not? Or are you sending a payment to somebody else? You want to know, did it go through? You don't want to like wait to get a text message 5 minutes later if it went through. Or someone's loading a page and you want to show them a bunch of recommendations. You want to show like recommendations now, not later on. And so there's like a whole bunch of these examples where like that kind of speed matters. So they think about, so now they think about like, how do we do this, right? Well, what is involved in this problem from an engineering perspective? The problem is we need super high uptime and reliability. Like number one, like we don't want this, any way we solve this to just like break things. Because if it breaks things, then like we're definitely losing money. But they have a bunch of data that comes from the customer. It comes from some recent data source, right? It could come from maybe the user session, 5 seconds ago in the user session or 10 minutes ago in the user session, also in some use cases. But the kind of common thread is this data needs to be processed really quickly and used in a machine learning application. So the recent context, the right now context, where is this user? Like, is this user in their home country? That's a really good fraud signal, right? Has this user tried to make 100 payments in the last 10 seconds? That's kind of fishy. Is the size of this transaction $1 million? That's kind of weird too. Like all of these signals, those things, people want to use them in their decisioning and use them to power their real-time experience. So that's a tricky data engineering problem. It's hard if you're a data scientist. So we have this engineering problem that's really high value. If you solve it, it's going to make a difference for your business. If you provide a better product experience than your competitor, and you want your data science teams to be able to do this properly, but your data science teams, they just know Python or R, and they've never done anything in production ever. That's the kind of situation a lot of companies are in. So how do you kind of bridge that gap? And how do you allow the data science teams to be able to build things that go to production and do it at a speed that is efficient, meaning like you're not paying for the data scientists for the whole year and they only put one thing in production, but they can launch things regularly. They have a good development and innovation velocity, while you're still maintaining all of the constraints you care about from an engineering perspective for the production system. High uptime, it's real-time serving, you're meeting your certain latencies, it works for your scale, all of these kinds of things, and like fits into your CI/CD process. You're meeting your data governance, compliance concerns, all of that. So that's the kind of like fundamental challenge that a lot of teams who are in this fintech, insurance, banking, e-commerce, gaming, security space, they all have some kinds of problems like this. And that's the core thing that the feature platform, real-time feature platform, is intended to solve. Any kind of like batch tooling, it just doesn't have any, it's like not related. And what people are stuck doing is it's literally, this is what the best solution is today. If you don't use a feature platform, it's hire a bunch of engineers and get them to custom build data engineering pipelines if you don't have or if you don't have a feature platform, and do that for every single feature. And that's a very expensive thing. Like this can be, okay, now I got to pay 10 people salaries for a year. I don't even know if it's going to work. The thing that they're going to build is going to kind of suck. It's going to break a lot, and it's going to be expensive to maintain. So that's where we come in, and that's where we hope, that's the kind of difference we hope to make for an organization. We say, don't do all of that. Just buy a really simple solution. We built that to help people get to production. Sorry, I just ranted on a lot, but I want to pause and let you guys interject however you want.
It's very good. Like for me, I understand the problem, right? But it sounds for me that there is a second, maybe less important. A question for you is, like where you felt was the biggest challenge here? Like the second part is serving, because I understand with Tecton you can, or online feature store, if you want to be generic, you can on one hand set a process for your data science team to develop features in a way that you can easily use them on production in a scalable, fast way in near real time. But so feature part solved, right? But then we also need to pass it through a model to get. But maybe this second part is, when I'm asking a question, maybe it's less challenging once you have those features under control.
Am I correct to think that the hardest problem for you to solve was the real-time feature engineering piece? Because to me, as an ex-data engineer and still data engineer at heart, like getting back from failures in real-time feature engineering pipelines is a mess, I would say.
Yeah, so I think there's kind of like there's a couple of parts here. One is the technical challenges in all of the real-time data engineering, and then the second is the developer workflows for the data scientists or the users, right? It's not always data scientists. And so it all comes down to this kind of like interface of a feature. So basically the innovation of a feature platform is, hey, you have this thing, you can define a feature, and as long as you kind of define it within the certain bounds of like what is its definition, who owns it, should it be online, offline, all of those things, then this system promises that it'll deploy it in this way, and it'll manage all of the infrastructure and all of the orchestration and all of the serving and everything for you, and it'll just be like productionized magically. And there's a bunch of problems there and behind the scenes that are solved, which are really hard, and we can talk about. But from the data scientist perspective, they get this nice interface. They just say, here's my little snippet of Python code. Here's my SQL query. Or maybe even using a DSL. Here's my like aggregation that I want to have in real time. And I get this interface where I can say, give me the real time feature value, the latest value that, my production system can plug into, or give me a training data set. Give me a historic, like backfill this feature, give me all this historical data, joined with a certain point of time, help me prevent label leakage, really high quality data set, right? So from their perspective, they can do that really fast, and it's like there's no engineer needed for them. They can just kind of like register, read features, share features. It's like a really nice interface for them. On the behind the scenes, kind of after they've registered, they put the feature in the central repository. That's where there's a lot of like really crazy technical challenges, where just some things to mention are, so we have a couple of there's some like really obvious things that are always there, like real-time serving. We have a lot of IP in how do we support all these different ways to do real-time serving, multi region failure recovery, things like that. Real-time feature compute. So we have a class of features which is computed using the data that comes from your application when you're trying to make an inference too. Like, you just filled out a form and you want to featureize that data as well to pass it to your model. There's we run Python in real time, and we run it really quickly so we can turn that into features and give it to your model. But then we also have, I think this is like one of the actually like the really nice values of the system that we've built that our customers really love. We have these modules that are kind of like managed feature pipelines. So a very common one, a very prominent one, the most popular one is the aggregations module. So, one very common type of feature that fraud teams use a lot is aggregations, literally time window aggregations or lifetime aggregations. How many times has this user made a purchase in the past 3 minutes? That's the kind of feature. If it's really high, there's something weird. Or how many times have they ever made, what's their total lifetime transactions with us? That's another trust signal, right? Doing that in real time at scale and meeting a certain level of cost efficiency, and being able to have the consistent data offline and be point in time correct, that's really hard. That's a the thing data scientists don't do, it's a hard problem for engineers. And we've just got this module that just kind of like automates all of that. We have like best in class implementation for it, and it's like super efficient. Our customers love it because they don't have to build, they don't have to invent this stuff. And so it's just another place where there's IP where we can make things easier for people and run like really highly productionized, best in class designed or best practice designed modern feature pipelines by just giving people like really simple APIs to define them. So I think that's kind of like a little bit of a walkthrough of the different systems. And of course, there's kind of like monitoring and governance and sharing and a UI to see the catalog of all the features. But I think like the things I just mentioned are like the unique differentiators and like why you would buy the system, why you would like use it. Does that make sense?
Yeah, but is it a secret? Is it a secret what kind of stream processing framework you're using behind the scenes, or is it something completely custom?
We actually have two. So yeah, so there's three kinds of. We'll just take a step back. There's three kinds of features generally that you can think of. One is batch, super obvious. It's like here's a SQL query. We'll run it on some schedule, and that will be the new feature value. Second is streaming. So that could be a streaming aggregation or any other kind of like streaming operation you want to run. No, that's good for like session type things, like how many dollars have you spent in the last 30 minutes? And then the third is this real-time feature compute, which is like right now synchronously coming in from the request for the person to sign up for insurance. They filled out all these forms, they gave us all this information, we got to process it right now, turn that into features, and then make a prediction with it. And so you're
Are
kind
you
of
doing the
talking
third
about
one? And are you
yeah,
doing
we
the
do all
third one
three.
as well?
We do all three.
Oh,
Yeah, yeah.
I didn't know that you're doing the third.
So number
And
three is like we've got a whole like real-time execution engine that kind of makes that super easy for people. So that's a really big thing for us actually, and fraud teams love that. But the
what
second
about the
one is
second? Yeah.
yeah. So the second one, that's kind of like the streaming thing, and so we have kind of two answers here. So we will both plug into, if you have like a Spark cluster, if you have Spark, we will run a lot of the streaming compute on top of Spark, use Spark structured streaming, and give you the flexibility to run whatever kind of Spark stuff you want. But we also run our own kind of streaming compute engine. This is kind of like developed within Tecton, but focused on these like specific performance optimized feature pipeline modules, like this aggregation thing I was just telling you about. So you don't need Spark, and you can come to Tecton and you just say, look, I've got a Kafka stream, it's got transaction events, and I need to know exactly how many events happened in the past X, just like basic aggregations and some more complicated stuff. And you don't need Spark for that. It's something we built, but we can achieve a level of performance that you can't really find elsewhere because we're doing optimizations that are really specific for the ML feature engineering pipelines rather than like generic data streaming use cases. Does that make sense?
It does. I was wondering if maybe you're using some Flink clusters underneath for doing
We don't
it,
use Flink.
or
No,
okay.
I know like we actually used Flink at Uber, so there's nothing, don't have anything against Flink. We used Spark originally at Tecton, and we've had a lot of the new stuff we're building to be so you don't need Spark. So folks who don't need Spark should be able to come to Tecton and have like a really great experience as well.